project is called GitGuild. Guild is sort of like a DAO, but we don't really believe in autonomy for these things. This is more a way for people to interact and to mediate their disputes. We say it's for governing a Git repository, but really you can put anything in a Git repository, so you could govern just about anything with this. As I mentioned, we are looking first at FLOSS, free and open source projects and methodologies that are in use. We think that there are a number of problems with this way of developing that are not being well addressed. For one thing, the contributors come from all over the world with many, many different skills, but each of them is subject to localized law, which is its own specialty that probably your developers and contributors aren't experts in. This creates a situation where the overhead is very, very high. You need lawyers in 12 different countries to make proper licenses and agreements with all of your different contributors, which is a big problem for profit. If you have a very, very high overhead, we can talk about revenues for open source projects later on, but if you've got too much overhead, it doesn't much matter. And finally, some of the procedures and kind of interpersonal team dynamics that happen in these projects are very different from traditional business. It's very hard to protect your project, your capital investments. People do things like forking and just, oh, we're now a duplicate product. And it's very hard to deal with those in contractual terms and to still run sustainable businesses, fund your development, so on. So these are the problems we're trying to address. We've done this in a peer-to-peer way using GNU-PG identities. Okay. GNU-PG is open source, pretty good privacy PGP implementation. We'll talk more about that later. We use Git to store all of the data. So Git is essentially a file system. Most Git developers get pissed at me if they heard me say that, but that's how Linus Torvald originally developed it, a place to put your files. And it stores all of the source and contracts that we will be governing in our repositories. And the third the third technology leg of the Git Guild is Ledger CLI, which is a plain text double entry accounting ledger. It's plain text, so it fits very, very neatly inside of a Git repository. To go a little bit more in depth in these, Git uses a data type called a directed acyclic graph, which is to say that it must go forward, you can't go backwards, you can't revert something in the past, and there are a number of possible forks and remerging patterns that you can take. These work very well for human interactions, where human teams will often fork and then recombine as they work. But it's very different from the Bitcoin blockchain and other blockchains that have existed, which are not allowing recombining and a number of the possibilities that DAGs do. Another interesting part about the Git tree, the Git file system, is every document has a SHA-1 hash. And in fact, every version of every document has a SHA-1 hash. So naturally, each document becomes something that could be treated in a cryptographic proof and can be, as the chain progresses in one direction, can become immutable. And finally, these documents, these revisions are grouped into commits. So you don't just change a single document, you change a batch of documents, and those are all signed together, including the parent hash. So this is how you get a immutable chain out of it, not just individual immutable blocks, right? So that's, are there any questions on Git before I move on? Oh, you're pretty technical, so I'll rush through. GPG, we're getting more advanced. This is a pretty widely used encryption tool. You can use it to encrypt, decrypt, sign, and verify just about any sort of document. It's very commonly used with email or with just documents in general. But since Git version 1.79, which is about 3 years old. You've been able to use it to sign Git commits. So if you think of a Git commit as our block, this is where the first time through the Git technology that you've been able to actually sign your blocks and create an immutable chain out of them. And finally, our last technology is Ledger CLI. All of these are GPL3, by the way. They're all open source. Ledger CLI is perhaps the least known of these three technologies, but it's still, I think, 15 years old, very, very stable and well-respected program. It's plain text double entry accounting system, as I mentioned. And here we're getting into some of our implementation details. So at the top, we're looking at our account structure. So within our ledgers, we've defined this structure where the first level is always the user. The second level is an account type, which could be assets or liabilities or kind of general accounting categories. The third is the guild or repository. Then we're going into the Git tree itself now. You're drilling deeper into the Git tree to try to identify a particular change. So you start at the repository level, then you go into a branch, then you go into a commit, and finally you might have some metadata that has to do with that commit. We have a consensus system that uses this accounting software to count and record votes. The votes are in a currency called XP, experience points, which you get by doing peer-reviewed work. At least in our implementation of this chain, you get it by doing peer-reviewed work. So you could call it a meritocracy. We have been toying with the term proof of labor as opposed to proof of work. This is not computers doing work, but humans doing labor, and humans reviewing each other's labor. But regardless, as you see, the XP accumulates. You vote at the end of the account chain. So you vote on the metadata on a particular commit, and your XP counts for everything up the chain. So if a user makes a good commit on a branch and they receive a lot of votes for it, not only does that commit receive lots of positive votes and therefore perhaps make it into the consensus, but that user also has now gained a reputation within the system that they've done something good that has been peer-reviewed. And finally, you can define and transact other commodities of any other token. Ledger CLI is very, very flexible. Unlike other accounting softwares, you don't have to predefine all of your assets. It doesn't go off of a fixed list, the ISO codes or something like that. You can make up just about any string that doesn't have numbers in it and say this is a new token, this is a new commodity. When you combine this with the other, the signing and the identities and so on, you're actually issuing this commodity now. You're not just writing it down in a ledger, but you're creating rules and procedures that it now has to follow. So that's the high level for Ledger CLI. How we use this for consensus are we've created two special account types. So in addition to all your normal liabilities, assets, and expenses, income, the traditional accounting categories, we've created height and depth. So when you receive a vote, it's counted in your height account, and when you spend a vote, it's counted in your depth account. There are some more specific rules about when you're allowed to vote and how much you can vote, but basically the way we have it is that you receive voting power as you earn income in a peer-reviewed manner, and for each issue you can only vote, so let's say you've received 10 XP total for you, you can only vote 10 XP per issue that other people bring up. So at any point, the guild has a certain amount of certain height that it is issued to all of its members. That is both the state of the guild, as it gets higher, then more things have happened that are approved by the members, and we can say that the guild itself has progressed. But we can also say that individual members now have more reputation and more voting power to spend on this issue or that. That's it for the high level. I want to give you a quick demo now. This is actually a shell script. It's working right now. It's an alpha version at the moment, but you can use it to manage a repository, which is the basic thing that it's supposed to do. A lot of these commands you can see are pretty similar to the Git commands. You've got clone, push. We've added fork, actually, which is kind of meta Git commands that gets added on through services like GitHub. And really what we're doing, what this script does, is it helps you use Git in a very compliant, very strict way. So it ensures that every time you push, you're signing your commits, that every time you merge somebody, you're checking all their signatures, that not just that somebody signed, but that the person that signed is in the list of members of your guild, that the ledger of the merge has sufficient XP votes, it has sufficient consensus to be merged, and so on. The transactions themselves are patch files. So we can actually look, let's take a look at, one of them now, the fork repo contract, if you will. So who's familiar with diff and patch? A few people, okay. So a diff is a way to tell the difference between two files, and a patch is a way to describe the change between them. So we use patch files as contracts to make changes. So when you want to fork a repo, you run this contract. We've parameterized a few fields by putting triple angle brackets around them. Those will get replaced at runtime. But otherwise, these two files are changed in the described way. So getolite.conf will have this one line added, and our transaction ledger file will have this fork repo transaction added to it, including the full chain up to the parent hash and whatever voting power you have as the grading user you assign to your own transaction. These patch files are very, very powerful. You can run them in reverse. So if we want to run this one now, I think I have it in my history, so I'm just going to go up. If we want to run this one now, we can say tx build fork repo, and we can fill in some of our variables. So what this is doing, it runs that patch. So now if I do git status, you'll see that getolite.conf has changed, our transaction ledger has changed, and we've done some other processing. So if we try to see in detail what changed about getolite, for instance, we see that, well, I ran this twice, so it did it twice, but we see that it added this one repository, which is the one that I listed above. If we look at the transaction, it filled in the hash with the previous hash in the tree. And you can see that it already filled in with my current amount of experience. I have 4 XP to spend, so it automatically assigned my 4 XP to the transaction that I created. Other people can assess my XP and these votes independently. So if I submitted this to a group and said, this is my contribution, my pull request, I have 4 out of the 40 XP votes, and I'm saying yes. They can all independently count my vote as opposed to the group, count how much that is out of the total, say it's 10%, it's enough or it's not enough. And they don't need any particular action from me at that point to merge it or decide to reject it ultimately. Finally, another thing about patches is we can run them in reverse. So if we now wanted to check this last transaction that we just ran, it's going to PGP encrypt everything. Yeah. You can see it didn't. Oh, it did. It said equity of parent was not used for this commit. So something I did when building that, probably because I ran it twice, caused it to give me an error when I reversed the patch, right? So this is how you would check a commit that you just got from someone else. They would submit it to you, and they would say, here's the patch that I applied to achieve this commit. You would then run the patch in reverse. If you got the previous commit exactly out, you would know that that exact patch had been run, and therefore whatever rules applied to it, you could safely apply to that commit. That's pretty much it. It's still alpha. At this point, the only contracts there are mostly for helping people manage a repository. But obviously, you're embedding a ledger inside of a chain. You can issue cryptocurrencies within this. You could make pretty basic, not just basic, you could make very advanced smart contracts. You could actually tie these into real-world arbitrators or jurisdictions in ways that other smart contracting systems can't do, because the natural language of this system is text or English or something compatible with lawyerese. So what I see this being used for is really governing projects themselves. It's not, though it is a blockchain, you can look at it as issuing cryptocurrencies. It's not meant to be a competitor to Bitcoin. It's not meant to scale to the whole world, to be transactional currency or anything like that. It's more for a team that may be distributed, that wants to organize and manage themselves in a peer-to-peer fashion, and maybe even have income and distribute the pay to their members without banking, without the traditional overhead. So are there any questions?
I have a question. I'm sorry. I think I might have